This is a video from section 3.10. Suppose we're given y equals f of x. And what I want to do is find the equation of the tangent line to y equals f of x at the point a f of a. Now, the slope of the tangent line to y equals f of x at a f of a is given by f prime of a, right here. So the equation of the tangent line is then y minus f of a is equal to f prime of a times x minus a. And if we solve for y, we get y equals f of a plus f prime of a times x minus a. Now, when x is near a, we can use the tangent line at a f of a as an approximation to the curve. Now, let's take a look at that. So if we pick a nearby value of x, let's say right here, and if I follow this value of x up to the curve, that's right here, right? And then if we follow that value up to the tangent line, we're right here, and notice how these 2 points are pretty close to each other. The further out you go from A, the further apart these 2 points are. So the point on the curve and the point on the tangent line appear to be further and further apart the further away you go from A. So as long as x is nearby, like let's say right here, we can use the tangent line to approximate a corresponding y value on that curve. And I think that'll make more sense as we do an example. Okay, so again, when x is near a, we can use the tangent line at a f of a as an approximation to the curve. And what I'm going to do is replace y in this equation up here with L of x. And when I do that, I get L of x is equal to f of a plus f prime of a times x minus a. And that's called the linearization of f at a. Now, f of x, which is approximately f of a plus f prime of a times x minus a, is called the linear approximation of f at a. Okay, the directions say to find the linearization L of x of the function at a. And let's take a look at an example. So we're going to look at problem number 1, and it says f of x is equal to x cubed minus x squared plus 3. And a is equal to negative 2. Okay, so the first thing we need is we need to find f prime of x. So f prime of x is equal to 3x squared minus 2x. Now let's take f and evaluate it at negative 2. So wherever I see an x, I'm going to replace it with negative 2. So I get negative 2 raised to the third minus negative 2 raised to the second plus 3. And this is negative 8 minus 4 plus 3, which is equal to negative 9. And then if I take f prime of negative 2, I need to know what that is as well. That's going to be 3 times negative 2 raised to the second minus 2 times negative 2. But that's going to be 12 plus 4, which is equal to 16. So therefore, L of x is equal to, now we're going to get f of negative 2 plus f prime of negative 2 times x minus negative 2. That's how this works. And so let's fill in our missing pieces. L of x equals, now f of negative 2 is negative 9. So I'm going to write negative 9 plus f prime of negative 2 is 16. And then I'm going to multiply by x plus 2. And we can simplify this a little bit, right? And so this is equal to negative 9 plus 16x plus 32. And so therefore, L of x is equal to 23 plus 16x. And that's how we do problem number 1. Let's take a look at problem number 3. Now, on problem number 3, we have f of x is equal to the cube root of x. And in this problem, a is equal to 8. And now, cube root of x can be written as x to the 1/3. Okay? And so we need the derivative. F prime of x is 1/3 x to the negative 2/3, which is 1 over 3x to the 2/3. Okay? Now, f of 8 is the cube root of 8. And the cube root of 8 is 2. F prime of 8 is 1 over 3 times 8 raised to the 2/3. But this is 1 over 3 times. Now, I could write this, by the way, as the cube root of 8 raised to the 2nd. The cube root of 8 is 2. 2 squared is 4. 4 times 3 is 12. So we get 1/12. We're almost done. So L of x is f of 8, which is 2. F prime of 8 is 1/12. And then I'm going to multiply by x minus a, which is, in this case, x minus 8. And we'll simplify this a bit, since we're just looking for L of x, right? So this is 2 plus 1/12 x minus 2/3. Now, let's address 2 minus 2/3 separately. 2 can be written as 6/3. So we have 6/3 minus 2/3, which is equal to 4/3. And so, therefore, L of x is 4/3 plus 1/12 x. And that's how we do problem number 3. Now, suppose, let's look at these directions. Suppose I said, use a linear approximation to estimate the given number. So this is where it's really, really, really handy, okay? Now, so let's take a look at problem number 33. Suppose I had the cube root of 1001. And so there's a couple questions that I have, right? The first thing is we need to identify a relevant function to help us find the cube root of 1001. And I would submit to you the relevant function that we need is f of x equal to the cube root of x, right? The cube root function is what's involved here. Now, we need to identify a, okay? What can I take the cube root of nicely, I would say? That's close to 1001, I might add. And I'm going to let a equal 1,000. I know the cube root of 1,000 comfortably. You know, and 1,000 is close to 1001. Okay, cube root of x can be written as x to the 1/3. All right? Now, f prime of x is 1/3 x to the negative 2/3, which we've done in an earlier problem, which is 1/3x to the 2/3. F of 1,000, well, that's the cube root of 1,000, right? And this is equal to 10. F prime of 1,000, well, here, let's come up here. If I take 1,000 to the 2/3, this is the cube root of 1,000 raised to the second. But that's 10 to the second, which is 100. And if I take 100 and multiply by 3, I get 300. So this is 1/300. Okay. Now, this is going to allow us to find L of x. L of x is equal to f of 1,000, which is 10, plus 1/300 times x minus a. And let's remind ourselves, a is 1,000, right? So we're going to take x minus 1,000. And this L of x gives us an approximation to what f of x is when x is near 1,000, right? So in other words, I'm going to say f of x is approximately 10 plus 1/300 times x minus 1,000. Now let's find f of 1001, because that's what we're really looking for, right? And remember, this is an approximation, right? So I'm going to replace the x with 1001. So I get 10 plus 1/300 times 1001 minus 1,000, which is 10 plus 1/300. And I can write this as 3001 divided by 300. Now, let's check out what this is approximately. If I take 3001 and I divide it by 300, that's going to be approximately 10.003. Now, one thing to note, if you put the cube root of 1001 into your calculator, okay? If I put that in the calculator, I get approximately 10.003. So this is accurate up at least up to 3 decimal places. So it's really, really helpful, right? Now, let's take a look at problem 34. Suppose I want to approximate the square root of 100.5, right? Now, my suitable choice for f of x is going to be the square root of x. And what do I know the square root of nicely? Well, I know the square root of 100 nicely, right? And so I'm going to let a equal 100. Now, f prime of x is 1 over 2 times the square root of x, by the way, okay? Now, f of 100 is the square root of 100. The square root of 100 is 10. F prime of 100 is 1 over 2 times the square root of 100. But that's 1 over 2 times 10, which is 1 over 20. Now, we're going to look for L of x first. So L of x is equal to 10, right? That's the first part, right? That's my f of 100, plus 1 over 20 times x minus 100. And that tells me what f of x is approximately when x is close to 100. So f of x is approximately equal to L of x, where L of x is equal to that stuff on the right-hand side, right? So in other words, f of x is approximately 10 plus 1 over 20 times x minus 100. Now, what I want to know is f of 100.5. And in this problem, I want to make sure you guys realize what we're looking for, right? So wherever I see an x, I'm going to pop a 100.5 in its place. So I get 10 plus 1 over 20 times 100.5 minus 100, which is 10 plus 1 over 20 times 0.5. Okay? And this is 10 plus 1 over 20 times a half, which is 10 plus 1 over 40. And so this can be written as 401 divided by 40. And what is that approximate? What is that approximately, right? So if you take 401 divided by 40, right, we get 10.025. And in fact, it's exactly equal to 10.025. So we could put exactly. Now, what this is telling me is that the square root of 100.5 is approximately 10.025, right? And if you put this in the calculator, you get the following. You get 100.5 is approximately 10.024968828, etc. So it's really not bad. So a linear approximation can give us a pretty good feel for what that value is. And that'll conclude this video. And in this video, I gave you an introduction to linearization, and we worked problems 1, 3, 32, and 33. Okay, thank you.